Hello, today we'll see some applications on geometric sequences. First question. UN is a geometric sequence of common ratio r equal 5 and first term u0 equals 2. We are asked to find the first three terms of this sequence. First of all, what do we mean by common ratio? The common ratio is the quotient between any two consecutive terms of the sequence. So, in order to find the second term of the sequence or the third term of the sequence, we need to know what is the relation between any two consecutive terms in a geometric sequence. The relation between two consecutive terms in a geometric sequence is un equal the previous term to un is un minus 1 times the common ratio, which is r. So we are given that u0 is equal to 2. And then, in order to know what is u1, we need to take the previous term to u1, which is u0, and multiply it by the common ratio, that is 5. And therefore here, the u1 is equal to u0 times r, which is 2 times 5, which is 10. And u2 is equal to u1, previous term to u2, multiplied by the common ratio r. Then the answer is 10 times 5, and then it is 50. This is how we calculate consecutive terms in a geometric sequence. Now I can ask here a supplementary question. If we are asked to find the nth term in terms of n in this sequence, what can we do? The nth term here in this case is un minus 1, because we started by the first term u0, not u1. The number of terms between un minus 1 and u0 is n minus 1 minus 0, which is n minus 1, added to 1, we add 1, and then between un minus 1 and u0 there are n terms, and this is why the un minus 1 is the nth term. So from the given, that is the first term u0 and the common ratio r, we need to find the nth term. In this case, I need to use the relation between the nth term and the first term, which is given by the formula un minus 1 is equal to the first term times the common ratio to the exponent n minus 1. So, for example, if I have uk, it's equal to u0 times r to the exponent k. And here I'm looking for the nth term, so the rank of the nth term is n minus 1. We are given u0, it is 2, and the common ratio is 5, so it's enough to replace u0 and r by their values. So the answer will be un minus 1 is equal to 2 times 5 to the exponent n minus 1, which is known by the explicit formula. In the second part, we are given un, a geometric sequence also, knowing that u0 is the first term, and that's equal to 3, and the common ratio is 1 over 2. We are asked to find or to calculate u6. Also in this part, we need to find the relation between the nth term, or the term of rank n, for example, and the first term u0. The relation between any term of the sequence, of a geometric sequence, with the first term u0 is defined by un equal to the first term times the common ratio to the exponent n. Just by replacing u0 by its value and r by its value, I can calculate u6, knowing that n is equal to 6. So u6 will be equal to 3 times half to the exponent 6. So u6 is nothing but 3 over 64. Now let's answer the supplementary question in the same part. Find the explicit formula, or also I can ask you find un in terms of n. When I say find the explicit formula, it means also to find any term called un in terms of the first term and the common ratio. The formula is un equal u0 times r to the exponent n, as we've seen before. Then we replace u0 by its value, which is 3, and r by its value, which is half, and here we will get un equal 3 times 1 over 2 to the exponent n, and this is the explicit formula, or un in terms of n. Now in question 3, un is also a geometric sequence. We know that u4 is equal to 12 and the common ratio is 2. We are asked to calculate u9. In this part, we don't know the first term, u0. We know u4 and we want to calculate u9. Then we need to have a formula relating u9 to u4. So we need to know the formula relating any two terms of a geometric sequence. So the formula is the following. The relation between any two terms of a geometric sequence is um equal to up times r to the exponent m minus p. And then u9 is equal to u4 times r to the exponent 9 minus 4. We know u4, we replace u4 by its value. We know r, we replace it by its value, and then we will have u9. So u9 is 12 times 2 to the exponent 5, which is 384. In part 4, we are given also un as a geometric sequence defined by un equal 3 times 5 to the exponent n. And we said that this is known as explicit formula. Determine the first term u0 and determine the common ratio r. Simply, to determine the first term u0, I'm giving the value 0 for n. So u0 is equal to 3 times 5 to the exponent 0, which is 3 times 1, and it's equal to 3. So u0 is 3 times 5 to the exponent 0, and it's equal to 3. Now to know the common ratio, I need at least two consecutive terms of this sequence, knowing that it is geometric, and I have to calculate the quotient between these two consecutive terms. So I know that it is geometric, and I calculated already u0. I have to calculate u1. u1 will be 3 times 5 to the exponent 1, which is 3 times 5 and 15. And therefore, to find the common ratio, I need to calculate u1 divided by u0. The answer is 15 over 3, which is 5. And this is the common ratio. Now the same question for another sequence defined by un equal 5 over 2 to the exponent n. Also u0 is 5 over 2 to the exponent 0, and then 5 over 1 is equal to 5. So u0 is equal to 5. And as we said before, to find the common ratio, we need to calculate u1 too also. And u1 is 5 over 2. Then the common ratio will be u1 divided by u0. u1 divided by u0 is 5 over 2 divided by 5, which is 5 over 2 times 1 over 5, and it's equal to half. Thank you.